Hello young scientists, in today's video we are going to explore the exciting world of thermal energy and how it moves from hot objects to cold ones. We will learn about the three main ways: heat energy transfer, conduction, convection, and radiation. By the end of our lesson, you will understand how heat moves around us every day. So we have this question. Uh, if we have soup has a very hot energy and the air here air is cold, okay, air is cold, here we have cold object, and the soup is hot object. Also the table here is cold object. So the soup was so hot from the question, so she decided to put it in refrigerator for a few minutes to cool it. What happened to cool? So the correct answer is the heat moved from the soup to the cold air. So always uh, the flow of uh, energy from hot object to cold object. Okay, so always from hot object to cold object. So thermal energy moves from regions of higher temperatures to lower temperature. So this is as a starter activity for today. So our learning objective for this lesson will be to understand where does thermal energy go, explain also. We are going to explain how does thermal energy transfer when objects are not in contact, and finally we are going to illustrate how else does thermal energy transfer in liquids and gases. So our keywords or vocabulary for today, we are going to uh, study thermal energy. What's the meaning of thermal energy? And we are going to study a closed system and open system, source object. What's the meaning of source object? Receiver objects, heat, temperature, conduction, collisions, thermal equilibrium, radiation, electromagnetic waves, and all of these vocabulary. So firstly, in which direction does heat flow? What's the meaning of heat flow? We know that heat flow means from hot object to cold object. So this is the meaning of heat flow. So energy flows from objects or area that have higher temperature to lower temperature. So if you want to answer this, we had this video which was to see how can you visualize thermal energy. We can use thermogram. Thermogram show us the temperature of an object by using color. We know that the hottest area here, it was red color, okay, red color was the hottest area, and the ground is blue color, which were the cold area. Okay, so the blue color, it was a cold area. Also here, if we want to look at thermogram, this one, we have a red color which was hot, and air and all of these things are cold. Okay, and we know that energy flow from hot to cold. When energy flow from hot to cold, which was from the toast to the air. So in which direction does heat flow from one object to another? Hot to cold. So this is the direction to this. So where does thermal energy go? So thermal energy means the total energy of substance depends on, first one, kinetic energy. And from the previous lesson we know the meaning of kinetic energy and potential energy, and the total number of particles, and also the type of matter that makes up the substances. Okay, we had this experiment and we do it together in laboratory. After that, we fill these things. What happened to temperature at the beginning? This was the initial and then T final, and what's the temperature of our laboratory. So here, have you ever forgotten about food that heated up in microwave? You might need it to heat it again because it loses energy. So if we want to talk about a system, as we mentioned in vocabulary, we have closed system, it's like microwave, and we have open system, which can exchange with air. Okay, it can exchange the heat with air. You know the direction or the flow of thermal energy. The meaning of objects make up the components of system. So the object that provide the energy, we call it source object. So now we know what's the meaning of source object. The source object means the object that provides the energy. Okay, what about receiver object? Receiver object, the object who gains the energy. Okay, we call it receiver object. In this example here, we have source object and we have receiver object. So we have the water, which is the small beaker. We have two beakers here. There's a small beaker inside the big beaker. Okay, if you don't see it clearly, the small beaker was hotter than the big one. So the energy transfer from the small one to large beaker. Okay, so the energy transfer like this from hot to cold. So if the small beaker releases energy, so it will keep losing the energy. So we say thermal energy decreases, it decreases until it reach the thermal equilibrium. But the receiver object, which is the large one keep gaining the energy, keep absorbing energy. So we say thermal energy increases in this way. Another example for this, if you want, so if you would hold a cup of coffee by your hands, we know that the coffee is hot object. So here it's hot, but the hand is cold object. So the energy transfer from hot to cold, as we mentioned before. So if the energy transfers from hot to cold, so the source object will be a mug, and the receiver objects will be hands. Okay, so if the mug keep losing the energy, so the thermal energy of the mug will decreases. So will keep decreasing until it's reach a thermal equilibrium also. But hands, it will absorb energy from the mug, so the thermal energy is gonna be increases. Okay, so here we have a few assessments. So you have to match the following vocabulary. What's the meaning again of system that exchange matter with the environment? We call it open system. Object that provide energy. What's the meaning of provide? Give energy. It's like source object. Object that gain energy, it's like receiver object. System that does not exchange, it like microwave, doesn't exchange energy with the environment, so it's a closed system. Okay, so here, as we see, if we want to look at this image here, we have two objects, object 1 and object 2. We see this is high temperature and this one is low temperature. So the energy flow from hot or from higher temperature to lower temperature to cold, as we mentioned before. So the heat flow will be from object 1 to object 2. Okay. So a substance can only be cooled by allowing some of its energy to be transferred to a substance of a lower temperature. For example, we have liquid water transfer energy to the surrounding in the freezer in order to freeze it. So if we put a water in freezer, so this one is water, and we are going to put it in a freezer. If I ask you to tell me where's the heat flow, you have to tell me the heat flow. It will be from the water to the freezer. Okay, so it loses energy until it's freezing. So that's what's really happened here. So to remember heat flow from hot object to cold object, so objects become cold by losing their thermal energy. So ice form because low liquid water transfers its energy to the surrounding air in the freezer. So when we put water here, so the heat flow, it will be from water to freezer. Okay, it will be from water down and up, from water to freezer. Here if we have these two objects, one of them red means hot here. Okay, and the other one is blue, which is cold, as we saw in thermogram. So if we put these objects together, they can touch each other here. So the thermal equilibrium, as we can see, what's the meaning of thermal equilibrium? Thermal equilibrium means two objects will have the same heat or the same temperature. So also if we put two objects, one of them 100 degrees Celsius and the other one is 0, we will put them together. For an example, 2 hours. After 2 hours, if we want to go and measure the temperature for both of them, we will find it same meaning, thermal equilibrium. So in this way both of them reach the thermal equilibrium. Okay, so let's go to see how energy transfer by 3 ways. I mentioned it at the beginning of the class, by conduction, convection, and radiation. So if we want to look at first one, conduction. What's the meaning of conduction? Conduction means transfer of thermal energy between materials by collisions of particles. So here we have, this is the hot particle here. It's gonna touch this one and this one. Okay, after that we will find both of them heated. After that it will touch this one and this one, like this. Okay, at the end we can find energy transferred from heated particles to nearby particles when they collide. Okay, when particles at different temperature collide, the particles with higher kinetic energy transfer energy to particles with lower kinetic energy. So conduction can occur between solids, liquids, and gases. Okay, we had this example also about the cup of water. We speak about it. So the other one is radiation. So how thermal energy transfer when object not in contact, like the sun? How can we get warmer when we stand at the sun? So the radiation, electromagnetic waves, moves from hot object to cold object by space. So it's transfer by space. Okay. Also, if we have a lamp has a higher temperature than the food here in microwave, so it transfer in electromagnetic waves. So this is one of our keywords for today. So what is electromagnetic waves? It's wave when radiation happen. So transfer of thermal energy from one material to another. So warm object emits more radiation than the cold one. So also in thermogram, when we look at this picture, so we can see different colors as we spoke about. So here we can see conduction between these things. Okay, and here we have radiation here. So conduction happened between the teapot and the table, okay? But high thermal energy when it was picked up. Also radiation happened to all objects. As I say, here we have radiation. Okay. So how the thermal energy transfer when object non in contact? By space. Okay. They can travel in space. We spoke about it. Now let's move to the third way of heat transfer, which is convection. So when we want, if I want to boil the water, if we want to look at this picture, if I want to boil the water, we have some particles, water particles or water molecules here. So it's gonna be heated and then it will go up. When it go up, we have space here, so the cold one will go down and then it will heat it again until all the water boiling and evaporating at the end if we keep it. Also, if we have fireplace here and I want to sit here beside it, so the hot air rises from here, okay, and the cold air in the room it were here, so it moved like a circle, so we call this one convection. Okay, we call it convection. Also it's happened inside the earth. Okay, so here we have a fruit pops. She placed the liquid pops, mold places them in freezer. So as I said before, the thermal energy transfer from hot to cold, from the liquid to freezer. So in summary, if we have discovered that thermal energy always move from hotter objects to cooler ones. We learned about conduction, where heat transfer through a direct contact, touching. Convection, where heat moves through fluids. And radiation, where heat travels through electromagnetic waves in space. Now you know how this process help keep our world warm and balanced. Thank you for your watching.